I have pulled from the teacher planner thing, the sort of the layout of what are the things we're going to do in the section. And so I'm just going to show you, you can always come back to this in your own time if you want to, but basically we talk about finding where the middle is. So central tendency. Can you tell me how do you work out where the middle of a data set is? And you'll see that word central tendency come up quite a lot. You will also see the word dispersion or measures of dispersion, which is a fancy way of saying how spread out is the data. So, is most of the data close together, or is it some of it close together, some of it spread out? How do we measure that? And that's called the measures of dispersion. Then what you'll also see us talk about in this topic is grouped data. So when you group data into categories or groups or intervals, and we'll also talk about ungrouped data, data that's standing alone and it's not inside a group. Then we will also talk about what's called the 5-number summary. So it's a whole bunch of statistics or measures that are important and a graph that you can draw called the box and whisker diagram that will come up. And then we'll also talk about graphs of grouped data. So when you have data that's grouped into categories, how do you draw graphs for them? And there's something called a histogram, a frequency polygon, and an ogive. These are the graphs of grouped data. And then we'll also talk a little bit about something called the standard deviation and the variance, which are basically measures of spread. They tell us how spread out a data set is, and that will also involve quite a lot of calculator work. So you can probably get away without your calculator today, although I'm not sure, but later on, you need to have a calculator with you. And then we'll also talk about symmetry in data sets, like if a data set is skewed to the one side, to the left or the right, and then what an outlier is. Okay, so that is the overview. Are there any questions or comments before I start with just having a little review of data? Or if you're ready to go, give me a smiley face. Let's see those emoticons fly. Thank you, Naledi. I like to see it. I love to see those fingers flying across the page. It makes me happy inside. Okay, so if we talk about data, like in the real world, you won't believe how many jobs involve data. This whole AI revolution that we're busy living through is basically just collecting up all the data on the internet from you and me, putting it together and making meaning out of that. And so in order to do that, we need a language that describes what's going on. So in the world of data, we have data that is made up of numbers. So we call that quantitative data, or sometimes people can call it like number data, data that's in the form of numbers. We also have qualitative. It sounds very similar, but if I had to really simplify it down, qualitative data is data that comes in the form of words or categories. Informally, it's like data as a number, data in the form of words or characters. Within the number data, we have what's called discrete data. So data that you can count and where you don't normally have half pieces, or if you do, it's countable. So discrete data, like you can count how many fingers you have, how many toes you have, how many people in the room. These are discrete data quantities. And then continuous data is data that can fall anywhere on a range. And we normally talk about continuous data being measured. So we think about like you measure how fast did someone run the 100 meters. You can always go like 9.842, or with Formula One, like 9.837. They really measure to very fine intervals. So I want us to just take a moment and recognize that number data can be broken up into discrete data and continuous data. Okay. So here is an example if you take the number of students in a class, that would be discrete data. It doesn't matter how short or tall you are, you only count as one person. If you roll a dice and you want to know the sums of those two dice cannot be 6.5. They can only be whole numbers. So this is also discrete data. Then for continuous data, we talk about human heights, time in a race, basically anything that you can measure. Okay, enough of me talking. Time for a multiple choice question for my students. Which of the following is discrete data? Which of the following is discrete data? And I'd love some answers from Busisiwa, Callan, Mikateku, Naledi, Njabulo, Pila. I know you've got some wisdom to share with me. I want to see it and hear it. Okay, Simon Keere has put a marker down. Which of the following is, let me turn my light on, so. Okay, so Naledi, what we're asking is, of the following, which of these data types is discrete? If Sam is that tall, we normally measure the height. We also measure weight. We weigh someone, we measure it to exact. We measure how fast somebody ran in the 100 meters. But when we talk about brothers and sisters, we are counting. And these can only occur in whole categories. And so the correct answer would be B, discrete data. Awesome, Naledi. I'm so glad. That's why I'm here. I'm here to help. And thank you for your question. Okay. Which of the following is continuous data? There is a cat who looks rather uncharmed with life. Which of the following is continuous data from this collection? Keep those answers coming, everyone. All right, you guys are clearly getting this. This is going to be the continuous data because she weighs that. These are all discrete quantities. So I'll put D, 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 and this is a continuous data item. So all we're doing at the moment is getting used to the language of data so that when we talk about data, we all speak the same language. And so you've learned two fancy new words today, discrete data and continuous data. Okay, now, it turns out not all data comes as individual items, or even if it does, sometimes you need to put it into grouped form. So where you create intervals and you group things together. So if I wanted to group this data set, what size intervals do you think would make a lot of sense? What intervals, since there's 4 spaces, how big should I make my intervals? Here's my data set. And I'd love someone to come online and just tell me what they think. There's not a perfect answer here, but it says here, data can also be placed into groups or intervals instead of a list. So this is a list of data points. It's almost like I've measured people in my class. Now, I want to put this into a grouped data table. I want to summarize it because I'm sick of looking at this long list. I want to make meaning out of this. So I've got this thing called a data table. And yeah, Bukle, let's go to you. You can unmute yourself. I think I've allowed you to unmute yourself. Can you hear me, Bukle? Hi.
Sir, can't we make it from intervals like 150 up until, let's say, 180 maybe?
Yes, I like that. Okay. Bukle said, why don't we try 150 to 180? And I think it's because you've just looked at it quickly and you said, where's about the bottom, where's about the top? Would you agree with that, Bukle? Like, is that kind of what you did?
Yes, sir.
Perfect. I like it. Now, I'm going to ask, has anybody else got any additions to Buchle's idea? So 150 to 180 is the first thing. I've got 4 spaces. Maybe I also spotted something at the very bottom. I spotted a 149. So I feel like maybe I should start at 145 and go to 155. So if I go to 145 to 155, that gobbles up the bottom bit. So, and then let's see, if I keep going, I get to 165, 175, 185. What's the biggest number? The biggest number is, okay, in stats, the maximum value and the minimum value are often important. And in this data set, the biggest value is 182. The smallest value is 149. And I'm using that to help me set my table up. So if I make this 150, in fact, this is going to be 156. Why? Who can tell me? This is another good question. Why have I made this 156 and not 155? I'd love a student to maybe explain why I started doing this as 155 and then I changed it to 156 because I realized something. And maybe someone can help me out. Naledi has smashed it. Naledi has said the last one ended on 155, and so it's already included over here. So sometimes what we do is we actually say where it ends and where it's included. So I don't want to spend too long on this, but I'm going to say, look, this includes 155. Let me zoom in. So this includes 145 to 155. This is 156 to 165. This is, let me make it smaller, 166 to 175. And then it's going to be 176 to 185. All right, I want you to complete this tally table. So the way the tally table starts is you take 169 and you say, which one would that be in? It would be in this one over here. Where would 155 be? It would be in that one. I want you to just quickly do a tally table, then a frequency, then a cumulative frequency, and I'm going to give you 2 minutes to do that. And when you're done, I want you to say done in the chat, because you're going to see this data table come up quite a lot in this topic. And I want to make sure you understand how to go from a list to a data table. So we're all working on finishing this, and then we're going to try and fill out the frequency and then the cumulative frequency column. Okay, let me try. Some of you, 149 would be there. 155 would be there. 175 would be there. 167 would be there. 159, where would 159 be? I'd be here. 166 would be here. So the tally is just keeping track of which things are. The frequency would be 4, 3, 4, 1. So there are 4 people who fall in the category 145 to 155. There are 3 people who fall in the category 156 to 165, and so on. Give me a thumbs up if you follow what I've done so far in going from a list to a grouped data table. Okay, now, something that's new in grade 11 that you're going to need to get used to is what's called the cumulative frequency. Now, the cumulative frequency starts at the bottom and says, how many do I have in the first interval? I have 4. But now if I say, look, I'm accumulating from the bottom, if I go to here, how many do I have? I've got 7. Because I've got 4, but then there's 3 more that are included. What do you think is going to come next in the cumulative frequency table? What do you think is going to come next in the cumulative frequency table? Okay, nicely done, Manila. I like it. It is indeed 11. And then the last one is going to be 12. So we actually know we have 12 data items in our list because the cumulative frequency table always adds up in the end to however many items we have. Something else, as I look at the list is great, but why is the table so much nicer and easier to read? I know I'm getting into like vague land. If I'm someone who sees a data set, if I see a list, it doesn't seem as helpful to me as a table. Why is that? Why does this table feel so much nicer to me? Does anybody have any ideas why maths teachers prefer these tables to these lists? Or scientists prefer tables to lists? Scientists are always making tables. Anybody have any ideas? You can pop it in the chat, I'll read it out, or you can put your hand up and I'll help you. Why do we like tables? Data people are always making tables. Okay. So the thing about the table is it's much easier to read because it's summarized. So a table summarizes data. The same way a graph summarizes the data. You can see that there are less people in this interval and most of the people are in the middle. And the reason tables are so nice is they take lots of little bits and they put them into bigger, meaningful wholes. And so you can then interpret the information so much easier when it's in a table. And so that's the way I would explain it. Does that make sense to you guys? Like, if you want to interpret something, if you want to make a decision, you don't want messy data, which is like all over the place and gives you a headache. You want organized data that you can see. Like, if you wanted to order t-shirts or long pants for a class, knowing this table would be much more helpful for ordering pant sizes than the data at the top here. Okay, I've talked enough. Let's go on to a few more new ideas. When we talk about a list of data, so now we're going back to lists of data. If I want to know where the middle is, there are 3 ways of finding the middle. There is what's called the mean or the normal average. There's something called the median, and there's something called the mode. And these are all measures of central tendency. So if you want to find the mean, you add up all the numbers and you divide by how many numbers there are. So in this class, if I wanted to know the average age, I would ask you for your age, I'd add it all up, and I'd divide by the number of people in the class. For the median, it's a little bit different. Let's think of the height for median. If you think of the height for the mean, you add up how tall you are, and you divide by the number of people in the class, and maybe you would get maybe like 160 centimeters. I'm just guessing. The median is when you take everyone and you line them up from smallest to biggest, okay? And let's see if I'm not very good at drawing, but you kind of get where I'm going with this. And in the middle of that list from smallest to biggest, you will find your median. Okay, so that will be the person who's kind of a height in the middle. So the height, the median might be like 162 centimeters. And it says here, you just list all the numbers in order. So you rank them from smallest to biggest and you choose the middle number. So that's the median. And then the mode is simply the value that occurs the most often. So in a list, whatever occurs the most often is the mode. So we've got these 3 words. So let's try this out. I want you to take this data set and I want you to find me the mean, the median, the mode, and something called the range, which I'm sure many of you remember from grade 9 and 10. But let's start with that. There's my list of data, and you are going to find me the mean, the median, the mode, and the range. And then, yeah, welcome to Aisha, who's joined us, and Sasipo, who's joined us, and Orenele has joined us. Welcome, everyone. Remember, if you do arrive a bit late because of sports practices or these things, the recordings are placed in on the YouTube channel, and there's a link in the Google Classroom. And so you can find that stuff there. Okay, to find the mean, I need the sum of all items and then the number of items. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 items, and if I add them all up, I get plus, or I get 37. I will have a look at the range. The range is the max minus the min, the biggest minus the smallest. Did you all get 37 divided by 9 for your mean? So like 5, 11, 16, 17, 20. Oh, I added up wrong. Sorry. Let me try this again. 5 plus 11 plus 4 plus 6 plus 1. I get 27. And so then the mean would be 3. Now the mode is quite easy because is there something that occurs the most? I think that just by looking at it, the 1 occurs the most. And Sasipo is quite right. The mode is 1. For the median, I need to rank the data from smallest to biggest. So what I'm going to do is I'm going to take those 1s, which are the smallest, and write them down. Then what's next? It's 2 2s. Then I've got a 3. Then what have I got? A 5. And then 2 6s. So if I want to know where the median is, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Basically the item that has 4. So for me, there are 4 items on this side, and there are 4 items on this side, which means that the median is what? What is the median going to be? Okay, the median is actually going to be 2. Now, I will actually teach you a formula for finding the median as well, but you can also find the median by just writing from smallest to biggest and then asking yourself, where is the middle? Okay, the middle is going to be here because you've got 4 below it and 4 above it. But you can also use what's called a position formula to help you. And so if I wanted to use the position formula to help me, I would say, how many items are there? How many data items are there? They're going to be 9. There are 9 data items. So if I want to find the position of the mean, then all I do is I use the formula n plus 1 over 2. Or some teachers say a half times n plus 1. So if I put a half times 9 plus 1, what number am I going to get if I go a half times 9 plus 1? Now remember, this is the position of the mean, it's not the value. You get position 5, okay? Or I put a TH there, the 5th position. So when you go back to your data set and you start and you go, this is position 1, this is position 2, position 3, position 4, position 5. Well, look at what's sitting in position 5. It is the median. I wrote that wrong. Sorry, guys. I made a little bit of a mess up there. This should be the position of the median, not the position of the mean. In the 5th position is the value of the median, and its value is 2. Now, I'm not sure if I confused you there, but give me a thumbs up if you understood what I meant by the position formula, and give me a thumbs down if that was like, whoa, whoa, whoa. Hold on, Brew. Settle down. Okay. So mostly I have happy students from what I can tell. Then the last one, the range is just the biggest minus the smallest. And so we're going to go 6 minus 1. And so the range is 5. The range is not a measure of where the middle is or a measure of central tendency. The range is a measure of dispersion or a measure of spread. It tells me how spread out, it tells me how spread out the data is, whereas these ones tell me where is the middle of the data. And so it's important to understand how these two things are different. Okay, everyone, we've done a half an hour of solid maths. It's important for our brains. We have a quick little break. We're not going to have a super long break. We're just going to stand up. And so we're just going to do a minute of relaxation, breathing, and exercise, and that's it. So please get up from your tables, get up off your bed, wherever it is. If you're somewhere else, change your posture so that you're not doing what you were doing before. And let's just take a nice deep breath. Breathe again. Okay, now we're going to do 15 jumping jacks to get our blood pumping so that our brains don't run out of the good stuff. So we're going to start in 3, 2, 1. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and I'm done. And I think I'm getting fitter because my heart rate is not pumping like it used to. Give me an emoji to tell me how you are feeling after our little break. I want to see how students are feeling. I like it, guys. I like seeing, I don't know why I love these emojis. I really do. So keep them coming. Okay, so let us look at another way of displaying data. So in grade 9 or 10, you may or may not have come across something called a stem and leaf plot. And what a stem and leaf plot does is it takes data that is normally in a list and it makes it more ordered for us. So it's almost like the stem and leaf plot. It gives us all the individual items, but it organizes it in a way that's easier to read. So the very first number in this data set is going to have a stem of 1 and a leaf of 1. So that makes it 11. The second data item in this data set is 12. The last item in this data set is going to be the value 72. So the data is ranked or ordered already for us, which is nice because you can kind of see where most of the data is sitting. Okay, so this is a nice, easy way of giving you a data set. What I want you to do is I want you to find me the mean, the median, and the mode for this data set. So off you go. I want you to take this data set. You are going to use these 3 measures of central tendency. And if you are stuck, I would love to have a question from you, because while students are working, this is a great time for me to give you some individual attention, if that is desired by you. Naledi, you are on fire at the moment. maybe we can help each other a little bit. We know for the mean, we need the total number of items. And in statistics or data, we talk about n being the number of items. Who has already worked out the number of items in this data set? Oh, some of you are using your calculator. That's completely fine. I will talk more about the calculator in later lessons. I just don't want to do too much on day one. So in this topic, calculators are very helpful. But for today, I'm just sort of keeping it reasonably, and then we'll learn about some cool shortcuts in using calculators later. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 items there. 1, 2, 3, 4, 5, 6, 7. 7 items. 4, 2, 4, 2, 1. 16, 20, 26, 29. Did anybody else get 29 items in the data set? Can anyone give me some support that they got 29 for their when they counted up how many items? Okay, Pufunzo's got my back. There we go. All right. Thank you, Sasipo. I'm feeling good about my 29. Now we need to add up all these items. Who is going to help me with that? Who is going to help me with adding up all these items? We need to go 11 plus 12 plus and all these types of things. At some point, we need to get this data set into our calculators. I do have it down here somewhere. I can actually, because I did it last year somewhere. Naledi, you must have, what is your sum for your data set? Should I just sneak here, see what I can pull up from last year? So what was your total here? Otherwise, I can do it. Should I do it with you? 11 plus 12 plus 13 plus 13 plus 15 plus 17 times 3 plus 19 plus 21 plus 23 plus 25 times 2 plus 27 plus 28 plus 30 plus 31 plus 34 plus 41 plus 44 plus 52, 3 plus 57 plus 58 plus 60 plus 61 plus 72. I get 935. Although I did add that up rather quickly, so I need to be careful. And if I divide that by 29, I get 32.24. And I see many students in the chat have got that. So this is 32.24 is the mean. What is the mode? Well, the mode is going to be the one that occurs the most. And to me, that looks like it's the mode. And so the mode is going to be 17. Now, to find the median, to find the middle, it's not easy to see where the middle is here. So I'm going to do a position calculation. Now, the median is sometimes referred to as Q2. So I'll explain why that is later in this topic, but the median is often referred to as Q2. And so if I say what is the position of the median, I can just use that formula that I used previously. And so that is going to be a half. Now, what is n? In this data set, what is the n going to be? Calendar has got a median there. So n is 29 because there was 29 items in the data set. So the position of the median is going to be 30 times a half, which is 15th. So you are looking for the 15th position in the stem and leaf diagram. Okay, let me slow down for a second. So Sivam Kele, for the mean, I need to find out what is the total number of items in this data set. And if I count, like here, 1, 2, 3, 4, 5, 6, 7, 8, 9, there's 9 items in that line. But if I add up all the other lines, you're going to see there's 29 data items in this data set. What I then did was, with my calculator, I went 11 plus 12 plus 13 plus 13 plus 15. And if I add up all the items in the data set, I get 935. And then I divided that by 29 to get this. Does that help, Simam Kele? Now, the 15th position is, I'm going to go to the 15th. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, what number is in the 15th position? What number is in the 15th position? What is the value of that number? Well, the stem is 2, so it's 27. So just to point out that the measures of central tendency don't have to be exactly the same. In this situation, we had a median of 27, we had a mode of 17, and we had a mean of 32.24. And when we get into what's called data interpretation, we are going to start to see if we get different means and medians, they do tell us something about the distribution, if the mean and the median are quite different. Okay, I'm not sure, I might have lost some of you. Give me a score out of 10. 10 means you perfectly understand what is happening. 0 means no understanding. 5 means, okay, I sort of get this, but I need to improve. What would your score be out of 10 so far? Keep those honest votes coming. Remember, I have to use those numbers to help guide my pace. Okay. So let's go and let's do this question. So this table shows us the average temperature in Fahrenheit. So it's not Celsius. This is a different temperature scale. The average temperature in London in January is 38. Then it goes to 39, 43, and then so on. It says here, the table shows the average temperatures of London, England for 1 month of the year. What is the mean of those values? I want you to use your calculator to help you, or whatever you can. What is the mean? And then which of the 4 options is the mean of that data set? So I know that there are 12 items. Now you can use some of you know how to use your calculator to do this, and that's fine. You can do it straight away. But just today, while we're doing this, this is 12 items, okay? And we need to now add up all these values and then divide them by the sum, the fancy thing for the sum of these divided by 12. Which option are you guys getting? 38 plus 39 plus 43 plus 6 plus 52 plus 58, 62 plus 62 plus 57 plus 51, 44 plus 42. I get a total of 594. And 594 divided by 12 gives me 49.5, which would be B. For bonus points, what is the modal temperature? What is the modal temperature? Doesn't really make much sense to ask this, but I'm going to do it anyway. What is the modal temperature for this data set? Well, the only one that occurs twice is July and August, and so that would be the mode or the modal month, or the mode is 62. If I had to find, this is such a good question. Okay, let's do it. I want to find the median month for this, and the temperature, basically in the median month. What am I going to have to do first to get the median temperature for the months? Why is it more work than the other ones in this particular situation? Why am I like, oh my gosh, I have to do some work now? Tell me in the chat why there's extra work if I want to find the median. You have to arrange it. Yes, Naledi. You have to write it from smallest to biggest. So what is the smallest number here? I think it is 38 and then 39. But then it's 42 and then it's 43 and then it's 44. What comes after that? 46, then 51, then 52. What comes after that? Okay, 57, then 58, and then 62 and 62. Okay, I've what's called ranked the data or ordered the data. We know there are 12 items in the data set. I want you to try and find me the median. What is the median going to be? And if you hit any problems, I want you to ask me a question about those problems. But over to you guys. Find me the median. If you want, you can use the position formula to help you. And then after that, you can find the actual median. Gadlin, you're spot on. Now, just a warning, what I notice is that the position formula isn't giving me a whole number. It's giving me a fractional number. What do we need to do when the position of the median is a fraction? It's not in the 6th or the 7th. It's in the 6.5 position. What do we need to do in that situation? Okay, Bukle, let's hear from you. I've unmuted you, I think. You can go for it.
We would take the 6th value and the 7th value, add them together and divide by 2.
Absolutely perfect. So basically you say, let's find it. So 1, 2, 3, 4, 5, 6. Okay. The median, or Q2, is between 46 and 51. And so you need to add those two together and divide by 2. So what do you get as your final median? Anybody have an idea? Helen, you have got it, and I see many others have. It's 48.5. So the answer for the median would just be 48.5. Okay, so we did another thing on the measure of central tendency. I think that that would have helped you get those ideas down. What I want to point out is that for the median, you need to arrange the data from smallest to biggest. So that's one key step. Then you need to calculate its position. And when you calculate the position, you need the n value. You need how many items you have in your data set. And then the final step is, if you have a position which is a fraction, you have to basically average it out between the two nearest values. Give me a score out of 10 for how well central tendency is making sense to you now.